Hello, everyone. Thank you for joining us today. On behalf of the Environmental Finance Center Network, welcome to the Intermediate Asset Management Series, where we're focusing on life cycle costing today. This training is being held for small water systems in Pennsylvania, Maryland, South Carolina, and Wisconsin. During the training today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box at any time throughout the session. We'll cue your question to be asked to our trainer. I would also like to draw your attention to the handout section on your control panel. The PowerPoint slide deck is available for you to download in this handout section at any time throughout the training. If you have any issues accessing that PowerPoint, please let me know in the questions dialog box. This webinar has been approved for or is pending approval for continuing education credits in Wisconsin, Maryland, and Pennsylvania. In order to meet the various requirements, we ask that participants interested in education credit participate in the training in the following ways. You must attend the entire 1.5-hour session. You must be registered and attend using your real name and unique email address. Group viewing credit will not be accepted. You must participate in all poll questions that will be given every 15 minutes throughout the training. If you have any interest in receiving credit, please submit an answer to the best of your ability, even if you do not know the answer. The poll questions will help you prep for the post-webinar quiz that is required to receive credit. You must complete this post-webinar quiz, which will show up in the follow-up email that's emailed to you an hour after the training. If you have any difficulty or miss a poll question, please reach out immediately to me in the Q&A. You must specify your operator ID and state when you registered to receive certificate credit. If you did not input your operator ID number and state, please submit that information in the questions dialog box at this time. If you have any questions or need assistance, please contact smallsystems@syr.edu. And for just a little bit about us here in the Environmental Finance Center Network, our program provides training and technical assistance to small public water systems in all 50 states and territories to help local water systems achieve their goals and stay in compliance with the Safe Drinking Water Act. And so on that note, we're going to jump right in. I would like to introduce our trainers for today's session. With us today, we have our team from the University of New Mexico's Environmental Finance Center. Please help me welcome Heather Himmelberger, Director of the EFC at UNM, and we also have James Markham with us, Research Scientist at the EFC at UNM. So I thank both Heather and James for being here with us today. And Heather, I pass it over to you.
Great. I will start sharing my screen in just a second here. It looks like that's shared, but if it didn't, please let me know.
We're good to go.
All right, so again, my name is Heather Himmelberger, and I'm the director of the Southwest Environmental Finance Center at the University of New Mexico, and I'm really glad to be here today talking about what is definitely one of my favorite subjects, asset management. And we're talking today specifically about the life cycle costing component of asset management. As we go along, we're going to have some poll questions and things to keep you engaged. And as was mentioned, it's very important that you complete the poll. And if you don't know the answer, it's fine to make your best guess. So life cycle costing is really about an examination of the entire life of the asset to optimize O&M, repair, rehabilitation, and replacement of system assets. So I'm going to start with a poll question that I'll let Savannah put up. And have you attended any other asset management trainings, either as part of the series that we're doing now on intermediate asset management or any other type of asset management training? So I'm just trying to get a feel for, you know, whether you've had a background in asset management before talking today about life cycle costing. And again, it's very important that everybody complete the poll so that we can make sure you get your proper credit. So if you don't know the answer, you can always put not sure, and most of the questions have that type of answer.
Thanks, Heather. And we're going to get ready to close this poll in 3, 2, 1. And so Heather, can you see those results?
Yes, I can. So it looks like we have most of us who have attended the other 3 sessions or some other session on asset management, and maybe only a couple of folks who have not attended asset management before. So I will recommend for those of you who were not able to attend prior asset management trainings, we have recorded lots of asset management trainings on our website. You can either access those through the Southwest EFC website, and it's really easy to find us. If you just type in Southwest EFC, we're the first thing that comes up on a Google search. You can also go to efcnetwork.org. And again, if you search EFC Network, the efcnetwork.org website is the first thing that comes up. So, either way, you can get the recordings of the other parts of asset management to kind of fill in some of the pieces that you might have missed. And one other reminder, I think was mentioned before, we have the questions dialog box. If you have any questions as we move along, please type them into the box and we will answer them. And if you're having a question, it's highly likely somebody else is as well. So please go ahead and type in those questions as we go. So to begin with, if we're talking about life cycle costing, we have to think about what the asset's life actually is. So it starts with planning, and oftentimes we don't think of that as the start of an asset's life, but that's actually the beginning of an asset's life, is when we are in the planning or conceptual design phase, where we're trying to think about what it is we're doing and why we're doing it and how we're doing it. And then we go into design, where we actually design where the assets are going to sit, how they connect to other assets, and all of that sort of thing. Then we get to construction, where we actually put the assets in the ground. We're installing them in wherever they're going to reside in the system. Then we have operations. Now that we've done construction, we start operating the plant. We have to maintain it. We have to do repairs as they come up. We have to do replacements and rehabilitation. We have to dispose of assets that we no longer need or no longer are useful to us. And then we have to have money to be able to make all of this happen. So the reason we care about the idea that the asset's life starts during the planning phase is because that's when you have the most influence at the least cost. So in this phase, in the conceptual design phase of things, which is this blue box over to the left, we have major influence. So here's our influence line, and it's at a very low cost to us. So while we're in design, we can make whatever changes we want. So for example, we choose to do a different kind of treatment. We want to put our well in a different place. We want to have a different kind of storage tank. All of those decisions are super easy to change in that phase, and they're very inexpensive. When we move on to the design phase, which is this blue box, the second blue box, our influence starts to drop as the design gets closer and closer to being finalized, and the costs start to go up. So in the beginning of design, we still have a lot of influence and the cost isn't too much. But as things start to really get finalized on the paper, it's going to be more expensive. We have to pay the engineer to change it, and that might cost us more money. It's still going to be less expensive than waiting, but we have to understand by the time we get to design, we have less influence at a greater cost. Then when we reach construction phase, which is now this third blue box, it's going to cost us a whole lot more money to make any kind of changes, and we have a lot less ability to make those changes. So when we're in construction, that's going to be when change orders are going to be required, and if you've ever been involved in the change order process, they're typically very expensive. And depending on how far you are into construction, it can be very difficult to make a change then. So if something is put in one location and you really want it in another, that's going to be a major change. So it's going to cost us a lot of money. And then finally, the last part of the process is the operation of the facility. So that last blue box on the right. And by this point, most of the costs are sunk. You have whatever assets you have, they're made out of whatever material they're made of, they're whatever size they are, they're in whatever location. And most of that is really difficult to change. So by this point, you have almost no influence, and it's going to cost you a lot of money to make a change. So this is why we really want to make sure that we see the asset's life starting much, much earlier in the process, because if we wait until we get the assets turned over to us after construction, there's not a whole lot we can do to try to influence, what kinds of assets, where they're placed, what kind of treatment systems, that type of stuff. So to address these realities, we really want to have a collaborative relationship between our operations, maintenance, and engineering, both internally, if you have any engineers on your staff, and many of you may not, but if you do have any engineers that are, internal to your system, you want to make sure that they're working together with operations and maintenance. And if you hire engineers to do work for you in whatever capacity, including design, you want to make sure your operations and maintenance staff are working very closely to them, because design and operations are inextricably intertwined. The best design is not going to achieve its intended purpose without good operations. And likewise, the best operations is not going to fix a poor design. So if the system was not designed properly, there isn't a whole lot you can do as an operator to fix that. Or if the system is designed really, really well, but people don't know how to operate it, that's not going to do you much good either. So it's extremely important that we think of operations as an integral part of design, that they're not separate, they're an integrated whole. So you might want to think to yourself of what are the typical interactions between your operations staff and engineering. Who gets to be involved in those discussions when you're talking about, the conceptual design phase or the detailed design phase, construction, like who gets to be involved in those discussions? What are the primary focuses of those discussions? Are they talking about maintenance? That's something that's often left out of the discussion, is if they give you certain kinds of assets, what are the maintenance and operation impacts of those decisions? For example, there was a utility that we worked with up in Massachusetts, and this particular utility had been on an operation where it was primarily a 5-day-a-week operation. It kind of ran itself, and they had mostly there during the day to just do certain things, but they didn't really need to have operators there 24/7. They needed to do some upgrades to the facility to have a little more capacity, and the design choice that they made changed the operations completely so that it had to be a 24/7, 365 operation. So overnight, this facility had to figure out how to have 3 shifts available and have night shifts and weekend shifts, and it was a very difficult change. And they said, we met with them, it was about a year later, they said if they would have fully understood those implications, they may not have chosen that particular option as the preferred, because there were a couple of different choices they had, but they weren't really focused on the operations side. They were much more focused on the footprint, the physical footprint of the plant and how it would fit a certain location, but they may have been, overlooking some of these other things. So it's really important that engineers and operations interact, so that you can get the best assets and the best operations and maintenance later on. So it really helps, when you have these sorts of partnerships, it's really going to help you operate and maintain the system afterwards. And the better the assets and projects are designed, the longer they're going to last, the lower the O&M overall, and the fewer repairs. So just one example that I wanted to share with you is a system in Iowa. And this system really took to heart the idea of having operations and engineering linked as closely as they could. So they created a 3D design model, and that's this picture up in the upper right here. And with that 3D model, the operators could kind of virtually operate the plant. They had little characters that they could, each of the operators could move around the plant, see how it was to get from one place to another, where assets were located, how they worked, that type of thing. And through that process, they actually noticed a couple of mistakes that were made in the design, things that an engineer might not think about. So if one was the hatch between the top floor and the bottom floor, where the intent was that you could drop assets from the top floor down to the bottom floor, and then they could be taken out via truck from the bottom floor. But the hatch was not big enough, so some of the equipment wasn't going to fit. Thankfully, they found that during this design phase. So instead of having the problem occur after the building's already built and you find this out, it occurred much earlier in the process, and they designed a door on the upstairs where you could take a forklift and get the equipment out that way. So had they waited until the building was actually built and have to put the door there, it would have been way, way, way more expensive than doing it up front. And another change they made was to put their control room in the middle of the plant instead of the back, and then having it have these glass windows so that as they're controlling the filters in this particular plant, they could actually watch what was happening. So it was a really good process for them, and it minimized their change orders. Their staff training was much easier after they got the facility, and they had fewer maintenance issues. And one of the quotes, or paraphrase quote from one of the folks that was involved in this project as an operator, said that others are handed a system and told to make it work. We were involved the whole time, and it was our system. And I think that's like super important, that you don't see it as, you know, somebody else's project that's handed over, but rather this is your project that you're intimately involved in, and even had a hand in making decisions and making the system better. And as they operated the plant, they felt that the operation was so much smoother than past projects that they've done, and that a lot of the problems that would have occurred that they would have found later, they found right away because of their heavy involvement with the engineering staff. So we have another poll question for you. So at your utility, are operators given a chance to input into the planning and design of new facilities? So you have a couple of choices, whether you have extensive involvement, whether you have some limited involvement, no, but we should do this. No, we don't think it's necessary. And then there's always the not sure choice. So go ahead and make a selection there. And again, just a reminder for anybody who might have signed on late, it's really important that you participate in the poll questions in order to get your CEUs.
Thanks, Heather. We'll leave this poll open for a few more moments to let folks submit their answers. And we'll get ready to close this poll in 3, 2, 1.
So that is great. We have some that have 18% that have extensive involvement. I am so happy to hear that. And then we have a 41% that have some limited involvement. So for you 41%, well, the 18%, I'm going to say yay, keep that up. For the 41%, I'm going to say please look at how you can increase that involvement, work from where you are now and try to increase your involvement. For the 12% who said no, but we should do this, please think of ways that you can involve yourself in that process. Then we have a few folks who don't think it's necessary, and I'll say try to keep an open mind, because I think it will really help you to have that involvement. And for those folks who aren't sure, it might be worth you asking within your facility how things like that are done, because again, I think it's a super important, often overlooked process where we really want to make sure that engineering and operations are viewed as two sides of the same coin. And I spent a bunch of my career on both sides. I much prefer being on sort of the operations management finance side of things, but I also did design, startups, all of that sort of thing. And I really saw this from both sides of how important having the two working together could be to a well-run, well-designed, well-executed project. So again, just keep an open mind. I think it would really help you to have that involvement. So the construction phase is another good opportunity. We talked about design for the last several slides. Construction phase is another opportunity to affect asset life. So think about the question of, does construction make a difference in how long an asset lasts or in how well they operate? And I will argue that it makes a huge difference. So I'm sure that any of you out there listening who are involved in, say, pipe assets, if you've ever seen pipe that was poorly installed, you'll have a lot more problems with that kind of pipe. For example, there's one utility that we worked with that had inadequate bedding sand, and they were having a lot of plastic pipe failures because there's a lot of hard rock underneath the pipes, and it was causing cracks and breaks in the plastic pipe. So instead of lasting, say, 75 or 100 years, the pipe was lasting less than 10. So thinking about construction, is really important, because if you construct your assets right, they're much more likely to last and give you the service you want. So keep that in mind too, that during construction, making sure you use the appropriate practices and that sort of thing is really important. But we're going to focus most of the rest of this session really on after construction. So after construction, you have to start operating and maintaining your assets. So this is where we hit the intersection of asset management and managing assets. So you might ask yourself, well, are they different? And the answer is yes, they are definitely different. So part of life cycle costing is thinking about what's strategic for that whole collection of assets. So all of the things you have in your system, your pipes, your tanks, your wells. And so that's asset management, is thinking about the collective and having plans for how you want to maintain things and thinking about how one asset affects another. All of those things are asset management. Another part of life cycle is actually thinking about individual assets and what's strategic for an individual asset. So this is managing assets. So when we talk about managing assets, we're thinking about what we're doing for an individual asset. So what kind of operation does it have? What kind of maintenance? What does that individual asset cost us? And both of them are important. So we don't want to say that one is not important, the other one is. We want to say they're both important. And this is where they really intersect, is in the life cycle costing, because we want to maintain and take care of our individual assets, but we also want to be cognizant of how that individual asset fits into the overall collective. So during this whole life cycle that we've been talking about, from planning all the way up to replacing our assets, there are lots of different ways that we can intervene in the asset's life. We can do operational things, we can do preventative maintenance, we can do monitoring, we can do corrective maintenance, we can replace our assets, we can rehabilitate them. We can inspect them, we can monitor them. So there's lots and lots of things that we can do for our assets, all along the way. And some of the interventions we talked about before in construction, design, and planning are also interventions in the asset's life. We're going to focus on the ones that occur after construction. So we want to start talking about operation and maintenance. And, I know that I sometimes even forget myself that operation and maintenance are not the same thing. So we always talk about O&M or operation and maintenance, and they're kind of run together like as if there's no difference between the two, but that's not really true. There's operations and there's maintenance, and they are interrelated. They're both important, but they are different. So the operations part are those day-to-day activities of using the asset to do the job for which it's intended. So if you have a pump, the asset is meant to pump. If you have a well, the asset's meant to produce water. If you have a tank, it's meant to store water. So the operations part is having that asset do what it's supposed to do. And the goal with operations is to maximize the uptime or operation of the asset. So we want it to do the job that it's intended for, as much as possible. So we don't want things to shut down the asset. We want to keep it doing its job. Now that doesn't mean that you necessarily run the asset 24/7, because sometimes we don't need to do that. Like we just need to pump to fill up a tank, for example. Maybe that takes an hour a day or 2 hours a day. So we're trying to maximize the ability of that asset to do the job we want. So if it's only the pump 2 hours a day, we're trying to maximize and make sure that it can do its 2-hour job. So that's our goal, is to make sure the asset is there, it can do its job, and it can do its job well. So what can interrupt this uptime or this operations time? What can affect your ability to do that? Well, there's 3 basic things: planned maintenance, expected failures, and unexpected failures. So planned maintenance are those things that you have to do. Maybe you have to inspect something. Maybe you have to lubricate something. Maybe you have to change filters, that type of thing. So these are activities we expect to do. We know we have to do them, and we'll want to schedule them so that they're least disruptive. So for example, if there's a time during the day where the asset doesn't have to operate, we want to do it then. Or if there's a time where having the asset shut down isn't going to cause a lot of trouble, that's when we want to schedule our planned maintenance activities. And then another really important part is ensuring that spare parts, supplies, and necessary staff are available to do the job. So you don't want to get started with doing a planned maintenance and realize, oh, oops, I don't have the right part, or I don't have the right lubricant, or I don't have the people who can actually do this. And then you end up, having the asset out of service for a long time. And we worked with a utility a while back where this was a routine problem, where the guys would go out to do a job and they would find out that the truck didn't have some part or supply or something that they needed. They would have to leave the equipment kind of broken down, go about an hour and a half to the nearest town, which wasn't even that tremendously large, try to get the part, and then come back. So the part or the asset was out of service for at least the 3 hours it took to make a round trip to town, plus the extra time, to purchase the product, get back, and get the repair completed or the maintenance completed. So super important that we keep, all of these things kind of, ready to go so that we're not going to have those kinds of problems. And we also want to question our assumptions about how we do planned maintenance, because just because we've done something one way doesn't mean we always have to do it that way. So here's an example of a utility that did question its assumptions with lubrication. So this particular utility would go through a complete lubrication of their treatment train. So this was their pumps along their treatment train. And from 2001 to 2014, every year they would go through and remove the old lubricant, put new lubricant in. So they used 54 gallons of lubricant a year, and it took 16 hours to do a complete change. And the cost was $2,100. In 2014, they did some investigation of lubricants, and they found one that was a food grade lubricant that had a much better wear properties. And it was stated that this lubricant would last 4 years. Excuse me, this lubricant would last 4 years instead of the one that they had been doing. So they decided to switch to that lubricant, and then they started doing lubrication analysis to make sure that it was going to last them beyond the 1 year period. So every year they would take 9 samples. They would take 2 hours to pull those samples, and the total cost with shipping and analysis was $520. So every year they go and do this, and they have found that they can go 4 years without changing the lubricant. So if we look at the triple bottom line benefits, and triple bottom line just means environmental, financial, and social is anything to do with people. So instead of using 54 gallons of lubricant a year, we would use 0. So over the course of the 3 years that they didn't have to change the lubricant, it's over 150 gallons of lubricant that didn't have to be used. And every year, instead of having 16 man hours, we have 2. So there's 14 hours that you can think about, well, what do I want to do with the 14 hours? So it's really important to think about how you can use efficiency to create time that now can be used for something else. And then on the financial side, instead of spending $2,100 a year, we were spending $520. So even though this is a small example, every time we do something like this, we're making an improvement in our system. So now we're going to have 2 polls, and this is going to be a little bit of thinking on your part. So I want you to think through the answer to this question. Which of the following activities would you think is considered managing assets? And I want to remind you that managing assets is something you do on individual assets as opposed to asset management, which is the collective. So when you're thinking about the activities that are listed there, creating a plan for how assets should be operated and maintained, assessing the risk of assets, lubricating a pump to ensure it continues to provide service, examining trends and performance of all pumps in the system, and looking at break rate data for all pipes. Which of those sounds like a managing assets question, which again is what you do for individual assets? So go ahead and take your best guess. If you don't know the answer, that's okay, just take your best guess. And again, as a reminder, please fill out the poll so we can get you your CEUs.
Thank you, Heather. We'll leave this poll open for a few more moments here to let attendees submit their answer.
And then as a reminder too, as was mentioned at the beginning, if somehow you miss a poll, let us know in the question dialog box right away.
Definitely, we'll record that as your answer. And you will get ready to close this poll in 3, 2, 1.
Okay, so we had a couple of answers that were selected: creating a plan how assets should be operating and maintained, and lubricating a pump were kind of equal. And then there's just a little bit of a small number of folks that said examining trends. Now the answer I would pick is lubricating a pump. So what we want to remember is managing assets is what we do to an individual asset, so the actual actions on the asset. And creating a plan for how the assets should be operating and maintained is more of a strategic look at all of our assets. So that's a little bit more in the asset management camp. And then examining the trends and performance of all pumps in the system, again, is a more strategic look, although it doesn't cover every single asset in the system, excuse me. It's much more related to asset management, where we're kind of strategically looking at all of our assets. And I know it was a little bit unfair of me to ask such questions because we haven't dug real deeply into it, but I just wanted to kind of give you a flavor for the difference between the two. And our next poll, which you can put up, Savannah, is the opposite question of what activities or which of the following activities would be considered asset management, which again is the bigger picture side. So lubricating a pump, performing maintenance on a well, to determine how often to rotate a bearing, using a risk-based approach to decide which O&M tasks to do, and inspecting a piece of pipe. Which one of those sounds more like the bigger picture asset management kind of look at things? And again, I realize it's a bit unfair because we haven't talked a lot about it, but I just wanted to give you a flavor of the difference between asset management and managing assets. And I do want to reiterate, you do not have to have correct answers for this to count towards CEUs. You just have to participate. So it's perfectly fine if you just are taking your best guess. That's all we need. This is just a learning opportunity, and we just want to have your engagement. It doesn't matter if you have the correct answer or not.
Thank you, Heather. We'll leave this poll open for just a few more moments. And getting ready to close the poll in 3, 2, 1.
And hey, great job, everybody. So that the answer of using a risk-based approach to decide which O&M tasks to do is indeed the answer I would pick, because this is strategically looking at all of your assets. And we're going to talk in a little bit of exactly how that risk-based approach works with O&M tasks. So great job, everybody, for most of you picking that answer, and all of the other answers related to things you could do to an individual asset. So they would much more fall into that managing assets category. So let's move on. We talked about planned maintenance. Now let's talk about expected failures. So expected failures are things that you expect to happen. These are parts you know are going to wear out. These are things that, you know, we expect this particular thing to break. And it might sound like a weird thing, like why would you expect something to break? But we know certain parts are going to wear out. So we expect that to happen, and sometimes we don't need to replace it before it happens. Sometimes we'll intervene through a planned maintenance to replace the part before it breaks. Other times we can just let it go. So an expected failure is something like a small diameter pipe in your distribution system. We expect over time there's going to be a crack, a hole, you know, some kind of break in that pipe. That's an expected failure. We know that will happen. And if it's a small diameter pipe that's really just serving a few customers, I don't have to do anything to prevent that failure. I could choose to, but I don't necessarily have to, because it's not a really high risk event. The consequences aren't that great. So I can just react to that failure when it occurs and fix the pipe. So that type of failure is an expected failure. And we can try to design out those failures. So one way we might do that is using different type of pipe. So if we're having a degradation problem where we have metallic pipe and our soils are really corrosive or our water is very corrosive and the pipe is starting to corrode over time, maybe we switch to a different material. Or maybe we design in some kind of cathodic protection or something like that. So there are ways that sometimes with these expected failures, you can change design or construction practices to try to prevent as many of the expected failures as possible. And then our last type of activity that might affect operations time or uptime is unexpected failure. So something that you don't expect to happen, some part that normally doesn't ever wear out, fails you, or some strange thing has occurred, and all of a sudden there's an unexpected failure that you have to deal with. You can try to eliminate them as much as possible, again, through better design and construction. So if you start observing unexpected failures, they can actually move from unexpected to expected. So if you see the same type of unexpected failure happening several times, it would probably change to an expected failure. You can also try to say, well, if this thing happened, is there a better way to have designed or operated or maintained or something else so that this particular thing wouldn't fail? And I'm actually going to use an example that's not water, but I've gone to some asset management conferences where other entities that are not water related, but rather manufacturing, do asset management. And actually that's practiced probably more in the manufacturing world than in the water world. And this particular one was interesting because it was the Cuties company. So those little cutie oranges, they actually practice asset management, and there's a conveyor belt for cutie oranges. And the cutie oranges would go across the conveyor. And I guess because some of them get crushed in the process, there would be juices that kind of fell down below the conveyor. And they were having trouble where the motor that was driving the conveyor belt would stop because the cutie orange stuff would get into the motor and kind of mess it up. And it was an unexpected failure because they didn't think that this was ever going to happen. And at first they didn't know why it happened. The motor just stopped. After it happened a few more times, they finally figured out that the juices from the cutie oranges were actually getting on the motor and causing the failure, and that the motor had been put in a place that wasn't good for the cutie operation, and the motor was kind of below the conveyor belt and it should have been put above. So they redesigned it to actually move the motor above the conveyor belt and stopped that kind of unexpected failure. So that's an example of how you can design out some of your unexpected failures and keep the asset in operational order. So how can operations improve asset uptime? So, doing things like unidirectional flushing of hydrants, shutting hydrants slowly so that it doesn't cause water hammer in pipe and cause pipe to break. So how we operate our hydrants can have an impact on making sure our pipes remain in operation. When we're doing a pipe break, we can operate our isolation valves so that, maybe we're in an area where there's 3 or 4 valves. If we start to operate those valves, that's kind of maintaining those valves so in the future they're going to work when we want them to. We can look at our pumps and maybe look at how we do our lead lag operation, whether we have variable frequency drives or not, whether there's frequent starts and stops, because basically frequent starts and stops are what really wear out a pump. They're really hard on a pump, so we can kind of address those types of things. With storage tanks, like how much of the tank is used, presuming you start and stop your tank based on levels in it, and not everybody does, but if you do, you might change what that level is, so maybe the pump starts and stops less frequently. So it's things like that that can really help you. And if you have any other examples, I put the chat, I apologize, it's actually the question box when you use GoToWebinar. I've been used to Zoom these days, and Zoom has the chat feature, but GoTo has the question dialog box. So if you have any other examples of how operations can reduce failures and increase uptime, I welcome you to write some other examples of what you can do operationally to kind of improve how you operate your, or how long assets remain up. And go ahead and do that. I'm going to move on in the interest of time, but please go ahead and do that. If you can think of any examples, please share them, and then James will let me know if any of those come in the question box. So moving on to kind of looking at the asset over its life and maybe some maintenance related issues. When the asset first starts its life, let me back up 1 second. So this is a chart that puts condition of the asset over time. So on the y-axis here, we have condition. And on the x-axis down here at the bottom, we have time. So the condition of the asset is basically at its peak at the beginning of the process, and then it's going to decay over time. Now, not all the assets are going to decay on this nice smooth curve. They can decay all different kinds of ways, but for our purposes today, we're just going to assume the asset has sort of this nice decay curve. And then at some point in the asset's life, you're going to reach this minimal acceptable service level. So that's the point at which the asset does not do what I want it to do anymore. So if it's a tank, it's not holding water properly. If it's a well, it's not providing enough water to me. If it's a valve, it's not opening and closing. If it's a meter, it's not reading properly. So there's a point at which it's not going to do the job I want anymore, but it doesn't get there right away. So it doesn't go from perfect condition to not doing its job overnight. It takes a bunch of time. Depending, the asset depends on how much time, whether that's, years, tens of years, many decades, that sort of thing. But at some point over time, it will reach that point. So at the beginning, we have the asset starting its operation, beginning its life, and basically the condition is good, everything is great. And then the asset, kind of falls off a little bit, but it's still in good condition. It's still doing what I want. And then time goes on and the asset kind of drops to more of an average condition. And I could intervene here with some kind of maintenance approach, and I could drive the asset back into a better condition. So that's one option I have, is sort of to intervene at this point to get the condition of the asset up a little bit, because again, it's starting to decay. If I don't intervene there, I can have a potential failure, which means that the asset is showing signs of trouble. It's still doing its job, but there's problems. Like I'm hearing a noise, I'm hearing or seeing a vibration. I can tell like there's something not quite right. It's not smooth operation anymore. So right here would be the potential failure, and I could intervene to prevent what's called a functional failure. When the functional failure occurs, the asset is no longer doing what I want. So at that point, when the functional failure occurs, I have to intervene or things are really going to go awry. If I don't intervene here to bring the asset back to its useful functionality, it's going to be a catastrophic failure, meaning I can't use the asset anymore. So I need to intervene here to prevent that from happening and kind of to drive the asset back up the condition curve. It might mean replacing some parts. It might mean doing some maintenance activities, rehabilitating the asset, something like that to get it in better condition. So anything I do prior to the potential failure is considered proactive work. So everything up to the point at which the potential failure occurs means I am getting in there ahead of time. Nothing has really bad happened to the asset. It's just decaying, it's just sort of losing its condition. So I can intervene anywhere along the way and keep the asset functioning properly and prevent a failure. Anything past the potential failure is reactive work. So something has happened that triggers me into doing something. So the potential failure, the noise, the vibration, I might see a little water leaking, whatever it is that sort of tips me off that the asset is not working the way it should. From that point forward, everything is reactive. I'm reacting to what I see. I'm not getting in there ahead of time to prevent the problem. I'm waiting till the problem occurs and then I'm going to react to it. So, think about what the ratio of reactive work to proactive work is in your facility. So is it 50-50, meaning half the time you're doing proactive and half the time you're doing reactive? Is it 80-20? Is it 60-40? Is it 30-70? And again, read chat in as use the question dialog box. So just think about your facility and, where do you stand? Do you do a lot of proactive work? Do you do mostly reactive work? And the first number should be proactive. So how much proactive do you do? Many utilities before they start asset management are much more in the mode of about 75-80% is reactive, and maybe 20 or 30% is proactive. And we would like to see that swapped. Through asset management, you really want to see the exact opposite. You would like to see about 70-80% proactive and maybe 20-30% reactive. You never would go to zero reactive work. There's always going to be those unexpected things that happen, and even some of the expected things that you're letting happen. But you just want the ratio to be much less reactive and much more proactive, because it's much, much cheaper to have a more proactive operation than a more reactive operation. It could be as much as 3 to 4 times cheaper to be on the proactive side rather than the reactive side. And I have actually experienced utilities that have as much as 90 to 100% of their work being reactive as opposed to proactive. And it also makes your day not a whole lot of fun.
Hey, Heather, we did get a couple of responses to that. We've got 20-80, we've got 80-20, and 30-70.
Great.
So it kind of runs the spectrum.
And it's something, if you don't know what the ratio is, it's something for you to go back to your facility and look at that. Because again, it's a very inefficient way to work. If most of your work is reactive, your day is going to be very unplanned. You're just going to be running around trying to deal with things that occur. And it's going to be a much more inefficient way to be. It's harder to plan what spare parts you need. It's harder to plan what time it's going to take to do activities. And then maybe what you wanted to do that day, you can't because some major event occurred. So again, if you don't know, go out and figure out, just do some quick assessment of where you are and maybe think about ways that you can change to be more proactive. And if you don't manage your assets, they will manage you. And the way they manage you is, again, by being reactive. So when you're managing them, you're in the proactive mode. When they're managing you, you're in the reactive mode, because basically they're telling you, when I fail, you're going to have to do something with me. You would rather be in the mode of, I will decide when I'm going to go and do maintenance on you. So if you choose not to be proactive, your assets will react and you'll have to deal with it that way. So if we think about the assets would manage us, we have to think about the question of, what should we do and when should we do it? So we want to look at the possibilities of what kinds of things you could do to your assets. And there are different kinds of maintenance that you can do. And different people use different definitions. So this, you could call your maintenance other things. That's perfectly fine. Some people merge some of these categories together. So I'm going to talk about 4 different types of maintenance that you could do. But again, you can have slightly different definitions, and that's fine. So one type is routine maintenance. This is when we're doing those normal things that we might do: inspections, lubrication, any kinds of adjustments we need to make, anything that's just a normal, like I do this once a week, once a day, once a month, those types of things that are just always happening. You're going to send somebody out to take care of these things, and they're just routine, regularly scheduled things. All of that falls under routine maintenance. Then we have preventive maintenance. And sometimes people include routine maintenance in preventive maintenance. So sometimes these are merged together. And preventive maintenance is just anything you're going to do to try to prevent the asset from failing. So you can do this after that potential failure, the sounds occur. And you can also do this anytime to try to prevent it from ever doing that. Like if you think that, if I don't realign my pump once a month, it gets out of alignment and I have a vibration. So you could do preventative maintenance before the end of the month to keep that vibration problem from happening. So it's any of that type of stuff. excuse me, corrective maintenance is anything you do to fix a problem once that problem has occurred. You know, something broke, there's a crack, it's not working properly. Corrective maintenance is anything you do after a failure. So corrective maintenance, pretty much by definition, is reactive type maintenance. And then the last one is predictive. So predictive maintenance is really, excuse me, is really about trying to predict when the asset will fail. So leak detection is one kind of predictive maintenance. Tank inspections, like if you ever put a diver in your tank, you're trying to predict if there's a problem inside that tank that you need to address. There are condition assessments that you can do in pipelines where you can get a company to come in and assess your pipes. You can do thermal analysis, anything like that, where it's giving you information. Even sending out the lubrication we talked about earlier, that's kind of predictive maintenance, because we're trying to predict based on what comes back on the lubricant, you know, whether the pump is okay or not, you know, is there something going to happen? So it's all of that type of stuff is predictive maintenance. So we do want to collect and analyze data to help us decide when we should perform maintenance and what type and how much to do. So we really want to have some information, because it's really hard for us to decide if the right schedule of lubrication is once a year if we don't have any information about that. So real important for us to do some data collection. So I have a poll question for you here. Do you collect data on your assets that can be used to help you determine trends or otherwise help you in decision making? So the different choices you have, yes, and it's in an easily accessible digital format. So meaning you have data and it's easy enough to use. Yes, you have it, but it's in several different places. Some of it's digital, so it might not be as easy to use as you would like, but you could still do it. Yes, but it's all in paper format and difficult to use. So if all of your data is in paper, you still have it, but it's just going to be more difficult for you to use it in trying to analyze trends that are going on. No, we don't track much data, or not sure. So go ahead and select your best answer out of those choices.
Thank you, Heather. We'll leave this poll open for a few more moments here. And getting ready to close this poll in 3, 2, 1.
So we kind of have a pretty good range on this answer. So most people were sort of in, you have some data, but it may not be in the easiest to use. Then we had a few people that do have easily accessible data. A couple people that don't track data or aren't sure. And I will say that that's pretty typical from what I've seen. Like the bottom 3 answers are very typical for smaller water utilities, is we have data, and sometimes lots and lots of it, but it's in the paper format, and that can be really difficult to figure out trends. Like, you know, if I wanted to ask somebody, you know, how many times has a certain alarm condition happened? The data is there, it's just all on paper, so it's going to be super difficult to actually tell me that type of information. But at least we have it. Sometimes the data is not tracked at all. So it's something, again, to think about at your own facilities, like how could you change your data collection practices so that maybe that data is a little more accessible, even if it's just an Excel spreadsheet. That can be a useful way. And for any of you who would be interested in moving away from a paper format to even just an Excel spreadsheet, we would be happy to provide no cost technical assistance to you to help you just even create a spreadsheet that you could put your data in, so that in the future you could have the information to do trending. So if any of you out there listening in want free assistance on that topic or anything else related to asset management, please reach out to us. We are happy to provide technical assistance. And I think at the end of the webinar, we'll probably give you more information about that as well. But keep that in mind, that we're happy to help you do that type of changeover if you would like to. So just a couple of predictive technologies on the screen. You can do thermal imaging to provide you information. And if you do that imaging over time, it can give you sort of trends on what's happening. You can do electrical insulation testing, which is also non-destructive, that tells you how assets are doing. You can do laser alignment to kind of help keep your equipment in good operation. So there's different techniques that you can use for predictive maintenance. I wanted to bring up the spare parts inventory side of things. It's often forgotten. If you think about where your spare parts are located, this is one of the best examples of a spare part inventory I've ever seen. And the gentleman who created this is a really, really good asset management person. He's also the maintenance supervisor at his utility. And he saw that the spare parts were kind of all over the place. They weren't organized. Nobody knew how many of what thing they had. People would often take more than one part because they didn't want to have to come back. But then if they didn't use all the parts, they never get back into the storage room. So sometimes there were even really expensive parts and, thousands of dollars walking out the door. And then when the guy didn't need it, throw it in the truck and forget about it. So it really needed to be handled in a better way. So he set about creating an inventory, and it's a really, really well organized inventory, and any part you need can be found in a matter of minutes, and they can track every single part. And they were literally able to tell me in a matter of a few seconds that the amount of money spent on spare parts in their facility was approximately $300,000. It was just shy of $300,000. So if you think about it, there's a lot of money sometimes that are tied up in spare parts, and we sort of overlook that. And it's not something you should overlook. You should think about, what are better ways to organize your spare parts, make sure you have the correct spare parts, and sort of understanding how much money is tied up in that. When an asset does fail, there are lots of options on what to do. And we have created for some utilities an asset failure decision tree of basically what happens, when the asset fails, what are your different options on what to do during the failure and then after the failure. And I'm just going through, this is a pretty long spreadsheet, so I've cut it up into pieces to put it on the slide. And we do have these available as a resource on our website. So when the asset fails, we have different options. We don't have to always take the same approach. We can actually decide we're not going to even need that asset anymore. We might repair it, we might rehabilitate it, we might replace it, or we might redesign it. We might decide that it shouldn't go back the way it was. We should have a different type of asset or design slightly differently to make things better. Because we really want to dig deeper. We don't want to just keep fixing something over and over again. We want to look at opportunities to improve it. So if the same types of failures are happening over and over again, we want to find ways to make things better. So I have an example here that's basically an example of a utility that didn't just fix something or do the job without thinking about it. They wanted to improve the situation. So this is a regular maintenance task that these guys had to do on a chlorine scrubber, and it was a really nasty job. And here's actually some of this chlorine matter on the ground because there was a leak in the tank when they were trying to fix it, and then they have to clean this soda ash accumulation off of the tank. So it's a really nasty job, and the guys would have to suit up. They'd have to wear some kind of breathing stuff. They'd have to really be careful because it was kind of some nasty stuff, this wet scrubber that they had to deal with, and they didn't like doing it. It was a very unfun job to do once a year. So rather than continuing over and over and over again to do the job, they wanted to retrofit the scrubber to dry inert media from that wet media that was causing so much trouble. And again, we'll go back to the triple bottom line benefits. So remembering the triple bottom line benefits include financial, environmental, and social. So what I'm showing on the screen is the financial benefits. So we didn't know precisely what it cost to do the initial construction. There wasn't any information available. But we did know what the O&M cost was for a 10-year period, and it was about $176,000. So every time they would get in there, it was costing quite a bit of money, about $20,000 a year to do the maintenance. And then the initial retrofit from the wet to the dry cost just over $100,000. And then the maintenance that we could track from 2013 to 2018 when we did this little study was $738. So instead of $20,000 a year, we had just, very little bit of money, about just over $100 a year. So we estimated what the 10-year cost would be about $1,267 total. So over an 11-year period, even considering the cost of the retrofit, there was going to be over a $73,000 savings. And every year, there's going to be almost a $20,000 savings. And that's just the financial part. When we think about the environmental part, cleaning out that media was creating a waste product that they had to dispose of in a proper hazardous waste disposal place. The inert media does not need to be disposed of that way. It can be disposed of in a regular landfill, but it doesn't actually get replaced unless something happens. So that the cost that they had every year was just monitoring. They would just take some samples to make sure that the media was still capable of absorbing chlorine. So really, they didn't even have a waste product most years. And then the social impact. So basically, the guys wouldn't have to go in and do this job that they really, really hated. So it was very beneficial from environmental, financial, and social. So considering these ways of fixing something versus, improving something versus fixing it is really important. So now I'm going to ask you sort of a fun question. So if a plane was maintained like your facility, would you fly in it? So really dig deep, because this is completely anonymous, your answer, and think about the poll question is going to be that if the airplane was maintained the way you maintain your assets, would you fly in it? And really dig deep in thinking about your maintenance program. If you have a really good maintenance program, you can select the first answer, that yes, and you would be very confident to fly in it. If you think you have an okay maintenance, yeah, you might fly in it, but you'd be a little nervous. If the third answer is, yeah, I don't really think I would, but probably it would be okay, most likely it would fly. The next answer is no, I absolutely would not get in a plane if it was maintained that way. And then the last answer is not sure. So this is sort of just making you think through, like, I fly a lot, at least I did before the pandemic, and I would like to think that my planes are maintained really, really well, because I have to trust that they're not going to fail in the air. And if we think about our water utilities, we would want that to be true also, that we're maintaining them very well so that our customers have really good water. So again, just go ahead and fill out the poll.
Thank you, Heather. We'll leave this poll open for a few more moments here. And again, just a reminder, if you are interested in receiving credit, please just select the answer to the best of your ability.
And you can always pick not sure if you don't know. That answer is there, and if that is the answer you want, that's fine.
All right, and we'll get ready to close this poll in 3, 2, 1.
Okay, so we don't have anybody that would be very confident, and that's pretty typical. We have split between you'd be a little nervous and it might be okay, and then we have some that absolutely would not. And that, again, these answers are very typical to what I find when I go out there. And I had somebody one time push against the idea that, hey, but we're not an airplane. And I say, but okay, how many people fly on airplanes, every day? And there's, let's say pre-pandemic, there were, probably, I don't know, daily hundreds of thousands of people. But how many people drink drinking water every day? It's over 300 million. So you guys touch way more people than airline mechanics do. So it's really, really important that we do our best to make sure that we have good, safe drinking water for our customers. And we do want to think about our maintenance programs. So if your answer wasn't yes, and that top answer, yes, with complete confidence, I would fly in it, it might be time to change some of your practices and really think through what you're doing and how you're doing it. So what maintenance activities do you do? When do you do them? How do you do them? What do they cost you? What impact do they have? So the actions that you're doing, You know, what impact do they have? Do they extend the life of your asset? You know, are the actions you're taking actually positive? So it might sound like a strange question, but sometimes people do lubrication incorrectly, or they over lubricate and cause a problem. Or I had one case where they were fixing pipe, but they fixed it wrong. And when after the repairs, they would end up leaking again because the repair was incorrect. So thinking about, you know, the activities that you're doing, are they having the desired result? And then why did you pick the approach you're doing? So kind of really thinking through that operation and maintenance. And there are actually quite a few resources out there that can help you develop an operation and maintenance plan for your facility. So when we look at efficiency gains, like this whole, what we've been talking about is really to help us gain efficiency. We can have efficiencies related to proactive operation. We can have an efficiency related to spare parts. We can even have efficiencies related to energy efficiency. So if we do activities to improve energy efficiencies, that gives us money because we've saved it in one area. We can use it in another. So you can think about the answer to the question, you know, what would you do if you had an extra $1,000, $10,000, $100,000? So if you make changes in one area, how can those go into another area? So that wish list stuff, you know, I wish I had money to do X. So think about what that X would be. You know, maybe there's a certain type of maintenance you've always wanted to do. Maybe there's a replacement that needs to be done. You know, what are those things you would do if you had more time or money? And you know, similarly, what if you had extra time? So let's think back to the lubrication example that I shared with you. There were 14 hours that they gained by doing the lubrication every 4 years instead of every 1. What would you do with the 14 hours every year that you've now saved? Or the scrubber example that I gave you, there are lots of man hours saved by the guys not having to get in and deal with the wet scrubber. You know, what would we do with those hours for some other job? So, you know, it's really important for us to understand that saving money or time in one area is basically so we can use it in another area. It's not about reducing the overall budget. It's really about getting to the backlog that you normally face in doing the work so that you can use it in areas that you really like to. And I always say, like, everybody should see you know, everybody should see a win in this process. So it's not about like, oh, let's see how much money we can save so we can cut your budget. It's really about how do we make your day more pleasant so it's more planned, you feel more satisfied because you're keeping your assets working, you get to do things that you've been putting off because you never have the money, and that type of thing. Now we're sort of going to switch gears a little bit because we want to keep our assets maintained so that we can provide the service level that our customers want at whatever risk profile we have, and using efficient life cycle practices. So one of the things we have to think about is whether we're investing enough to sort of maintain the status quo. So one option is you can incrementally invest, replacing assets, rehabilitating assets, that type of thing, and just keep everything status quo. So it's not going to get any worse, but it's not going to get any better either. So you're just going to keep it kind of locked in the way it is now. So however many breaks you have, water main breaks, they're going to still be there. So if you have 100 a year, you can maintain the facility to have about 100 a year. Or if you have, you know, 15 meter failures a year, you can have 15 meter failures a year. And there's a way to sort of make sure that we're investing enough to make that level happen. You can invest more than that level. And if you do that, things could actually get better. So instead of having 100 breaks a year, maybe we have 70. Or instead of have 15 meter failures, maybe there's 10. So you can actually invest to have a little better situation. Or you can do the third option, which is investing less. So if we invest less than what's needed to kind of maintain status quo, things are going to get worse. So instead of having 100 breaks, we might have 125, or instead of having 15 meter failures, we might have 20. So things would actually get a little worse over time. And the more we underinvest, the worse that acceleration will be. So we can either invest exactly what we need, more or less. And one way to kind of measure this, and there are certainly others, but one way to measure this is sort of this idea of the replacement cycle. So if you thought about what it costs to completely replace the facility that you have, and then you think about what do you invest in replacements every year, and this would be like an average. So if you thought about how much money you invested in replacements over the last 20 years, divided by 20, that's your average incremental investment every year. So it's a fairly simple concept. And when we talk about total cost of replacement, we can use pretty crude methods of doing that. And we have some tools available on our website. And again, we're happy to help you if you'd like to do this analysis. Please reach out to us. We're happy to help you kind of do a quick analysis of where your replacement cycle is. So if we divide total cost of replacement by the average incremental investment, that tells us our replacement cycle. So here's one example, and the top number, $5 billion, actually comes from the city of Albuquerque, where I'm right now in Albuquerque, New Mexico. Their water and wastewater infrastructure is valued at $5 billion. The bottom number is not exactly how much they invest. It's a different number, just for illustration purposes, but let's say they invested on average $25 million a year for replacements. If that was the case, the replacement cycle is 200 years. So what that means is they're expecting their assets to last 200 years. And I don't know about you, but I don't think most assets are going to last 200 years. I don't even think probably any of their assets are going to last 200 years. So it's really an underinvestment in assets. So again, there's sort of three scenarios with the replacement cycle. If you're investing exactly, or if your assets are going to last exactly 200 years, then your investment exactly matches the replacement cycle, and you're going to be at that status quo level. You could invest more than, or I'm sorry, your assets could last longer than the replacement cycle. So let's say our assets were really going to last 250 years. Again, not realistic, but that's another potential. And the last potential is that the assets are only going to last, say, 75 years or 100 years. So what's going to happen then is catastrophic failures are going to occur. So if the replacement cycle is 200 years, meaning I'm investing at that level, I'm not investing enough. Assets are going to fail, bad things are going to happen. And most cases are that people are under investing. And it's really important to sort of understand the risks of underinvesting and the benefits of investing more. So here's an example of an event you might remember. This occurred in Los Angeles. It was a few years back. There was a major water main break that happened by the UCLA campus, and the water was just squirting in the air. It was a 97-year-old riveted steel pipe under high pressure. The engineers had told the city that this pipe needed to be replaced, but they did not want to invest the money to replace the pipe, so it broke. So you're welcome to chat in, or I'm sorry, use the question dialog box to guess at the replacement cycle. So how long do you think they thought their assets were going to last, or based on how they were investing, how long were those assets going to last? And James, do we have any guesses?
Not yet.
Come on, somebody can guess. Just give it your best guess of what you think, how long you think they expected their assets to last. And think about, it's LA, it's a big city. Do you think they were doing well with their investment, or maybe not doing so well? Anybody yet? All right.
I'm sorry, it does look like we've gotten a few responses, and we've
Okay.
had 400 years, 100, 150 years, 75 years.
Great. Thank you for your guesses. And whoever said 400 years is the closest. So their replacement cycle was 300 years. So the level of investment at that time was such that they expected the pipe to last 300 years. And if your average replacement cycle or your total replacement cycle is 300 years, that means some assets actually have to last longer than that, because some assets will not last as long, because it's sort of an average replacement cycle. So what they were counting on is a completely unrealistic scenario. There is no way that the pipe is going to be there 300 years doing its job. So really what that means is that consequences were going to be severe. We were going to have some catastrophic failures. The backlog would be greatly increased. We had reduced customer service. And they kind of had this mindset that there's no cost to deferred replacement, that it's basically, so what if we wait? But the pipe is still going to have to be replaced after it breaks. Replacing during emergencies is much higher. Damages still have to be paid. That damage caused by that break was probably around the order of $300 million, so it was quite expensive. So now we have a poll question related to whether or not you know your replacement cycle. So go ahead and chat in whether you know your replacement cycle. You can either say yes, and you don't have to say what it is, but you can say yes. You can say you think so, but you're not sure. No, you never went through the process to figure it out. No, I didn't even know there was a replacement cycle, or not sure. So go ahead and give us an answer.
Thanks, Heather. Responses are coming in rapidly. We'll leave this open for a few more moments to let folks submit the best response.
And Savannah, I don't know if you noticed, but my system crashed and it kicked me out. And when I came back in, I no longer have access to the questions. Apologize.
Not a problem. I will upgrade you right after we close this poll.
Okay, thanks.
Of course. All right, and we will get ready to close this poll in 3, 2, 1.
These are the perils of technology these days. So congrats to the few people that said yes. We have a couple people that said they think so. A bunch of people that never went through the process. Several people who didn't know what the process was, or that there was one, and not sure. And again, that's pretty typical. And if you would like help kind of thinking through your replacement cycle, please reach out. We're happy to provide, and again, it's to no cost to you, provide assistance in this area of asset management. All right, so going back, now we're going to move on and talk a little bit about capital improvement plans. And this is where we're just trying to have a listing of what it is we want to replace and when we want to replace it, how much it's going to cost, that kind of thing. And this really relates to risk, which would have been the subject of the last webinar. So again, if you didn't go through that webinar, please pull up the recording about criticality and risk, because this is where this information is coming from. So every asset kind of has a risk, meaning its likelihood of failure and its consequence of failure can be plotted. And those assets at the top right are very likely to fail and its bad consequences. Assets in the bottom left are not likely to fail and it's not bad anyway. These assets are likely to fail, but it's not a big deal. These assets are unlikely to fail, but it would be a big major deal. So this risk helps drive our capital improvement plan. So the things that are in the high risk category are what we're going to have to replace in the short term, these next 1 to 10 years. These types of assets in this risk category would be our midterm replacements, say 10 to 50 years, because they're going to over time get worse if we don't intervene. And these are our long-term replacements, the ones in the low risk category, because they're doing well. It's going to be a while before they get up into a higher risk category and need to be replaced. These are going to be our emergency replacements, where we're going to let them run to failure, and we'll call it a managed failure. So we want to have some money available, but we're not going to replace them until we have to. We're going to use the whole life of the asset. So we can create short and long-term CIPs, short-term being 1 to 5 or 1 to 10 years, and it's very much more specific project costing, prioritization, justification, and we really want to justify all of our high dollar projects. We want to go through a process to evaluate, why are we doing this? What are the alternatives? Analyze those alternatives and really think about, how to justify spending that money. Is it really worthwhile doing that? And then as we look at risk, we can use the available funds to, complete the higher risk projects and that type of thing. So in the long term, we'll have rough costing, no prioritization. We don't really need to worry about in a given year one project being prioritized over another. Everything can be equal weight, and we don't have to do justifications for our long term. We're just trying to get some rough costing of, over the next 50 to 100 years, what's going to have to be replaced. So that would be your pipes, your treatment plants, your tanks, all of that stuff. And it's just sort of a rough guess based on that useful life estimate you would have made during the current state of the assets for how long you think that asset is going to last. So now we have a poll question to ask you if you have short and or long-term capital improvement plans. So the short term, again, is those plans that cover just the first couple of years, 1 to 5 years or 1 to 10 years. The long term are those ones that are more than 10 years. So you're looking at 20 years, 50 years, 100 years down the road. So do you have both short and long term? Do you just have short term but not long term? Just long term but not short term? Do you have neither, or you're not sure? So go ahead and put in an answer to this poll question.
Thank you, Heather. And we will leave this poll open for a few more moments here. And getting ready to close this poll in 3, 2, 1.
Oh, fantastic. We have a bunch that have both. That is absolutely fantastic. And then we have some who have a short-term but not a long-term plan. We have some that have long-term but not short-term, some that have neither, and some that aren't sure. And again, this is another area if you would like help on capital improvement planning. This is another area that we can work with you on. So please let us know for anybody who maybe isn't satisfied with the CIP planning they've done thus far, or just even wants to learn a little bit more about what could be in a short and long-term plan, please reach out. We're happy to help you. All right, so now we're coming down to the review, and we're just going to go through some points to take away from today. It's really important to consider the whole life cycle of the asset, and remember the asset's life starts in the planning phase, not when you're given the keys and have to make it work. And basically, I just said that. Operations is intended to maximize the uptime. There is proactive and reactive maintenance. So all the proactive work comes before the failure, all the reactive work comes after the failure. You should have both short and long-term CIPs. And then I have one last question to round us out here before we open up to any questions. Which of the following is not part of the life cycle of an asset? So if you think back to what we talked about, we have asset design, construction, maintenance and repair, planning, or they are all part of the asset's life cycle.
Thank you, Heather. We'll leave this poll open for a few more moments here. Responses are coming in. And again, just a reminder, this is the last poll question. So if you are interested in receiving credit, please just answer to the best of your ability. And we will get ready to close this poll in 3, 2, 1.
Fabulous, woohoo! That was fantastic because you are all correct. Every one of those items on the screen there is part of the asset's life cycle. And it's super important to remember that the asset's life does start much earlier than when you're just operating it. So thank you all for a great final poll. So now I'll just put my contact information on the screen. We also have the SWEFC email address there. We have the SWEFC website address there and office phone number. You're happy to reach out to us and ask for any kind of assistance that we could give you in asset management. There's also on the efcnetwork.org website, there's a place where you can go and select I'm trying to remember how it says assistance. Savannah, do you remember on the website, is it called request assistance?
Yeah, so I did actually put the link to the
Oh,
team right in the chat box. So for anyone interested, they can go right to the website, and just as Heather said, it's right under request assistance.
yes. So you're welcome to do that. We're happy to help you. And again, it is absolutely no cost to you. The only criteria is that you're a system, water system that's 10,000 population or less. So as long as you fit that criteria, you can be anywhere in the country. If you fit that criteria, we're happy to help you at no cost to you in addressing that or any other asset management type issues that you might have. Did we have any questions to address, Savannah?
So at this time, oh, go ahead, James.
I was going to say, so far we do not, although we do have a comment about not applicable not being an option in some of the polls. I apologize for that. It's because we have a limited number of answers we're allowed to use, but for future, we'll add NA to the not sure category just to make that a little bit clearer.
Great. Well, I again want to just put in a plug that if you were not able to attend for whatever reason the other sessions we had, there are recorded webinars available. You're welcome to look at those. We also have what we call our asset management switchboard, which collects all the free resources from state and federal places as well as our own in one place. You can get to it from our website. You can also search for asset management switchboard in Google, and it should be the first thing that comes up, or SWEFC switchboard, asset management switchboard, anything like that. And you can access a whole bunch of free resources. We have a newly released asset management framework that includes green and gray assets. It can be used for just those people who have gray assets, meaning engineered parts, pipes, tanks, that sort of thing. Or it can be used by people who have green assets or both. Sometimes you don't think about it, but your source water protection areas typically have green assets. So you might be using a forested area around a reservoir or around a stream or something where you're getting your water, or you might have a well where you're looking at the land around the well. And those assets or those natural areas are actually assets to you, even if you don't think of them that way. You know, those actually matter. So we also have that green-gray asset management framework that can be used. So there's lots of tools available to help you out in your asset management journey.
Thanks,
We
Heather.
had a couple questions coming in about access to recordings and slides from the prior sessions and where those will be hosted.
Yeah, so Heather, I can chime in right now. For this series of asset management from the EFCN, we have provided the recordings and the PowerPoint slides during the actual session and then in the follow-up email that was sent to you from GoToWebinar. So if you cannot locate those follow-up emails that again do provide both the PowerPoint and the recording, please email smallsystems@syr.edu. I have it noted here for the few attendees that have followed up directly in the questions box for this session. So I will reach out directly to you with that information. But again, for anyone looking to receive those materials, and if you cannot find that follow-up email from GoToWebinar for the session training, please email smallsystems@syr.edu. And I'll provide that email in the chat.
All right, so with that, I'm going to thank everybody for being on today. I know an hour and a half is a long session, and I appreciate your, hanging in there and listening in to the session today. So thank you very much for that. I think that about does it for us.
That wraps it up. I just have one last reminder for the follow-up email that's coming out after this webinar. There is a post-webinar survey quiz that is available, and that is a requirement for receiving certificates for credit. So please fill out that survey. Again, that's in the follow-up email. And if you do not receive a follow-up email or access to that survey, if you're looking to receive credit, again, you can please email the smallsystems@syr.edu. And thank you, Heather and James, for providing your expertise today. It was a great session. I really did appreciate the airplane poll question. I'll just have to throw that out there again. And
It's always a fun one.
it really is. But all right, we will get on with the rest of our day. And thank you for joining us and have a great rest of the day.
Thank you.